Hello there, friends. Tyler here. We are going to be installing a Turing signing server so that everybody can get up and running with Turing signing servers. So first things first, we're going to go to the repository, which is either going to be a tyvedh/Turing signing server or Stellar once we move it over to the Stellar repo. Once we're here, we're simply going to grab the URL for it, and then we are going to clone it. And I'm going to clone it on my desktop. And we'll open it up in our code editor. This might be a little bit small, so I'm going to blow this up a little bit. So there's a couple different things in here. We're not going to get into what the code actually is today. We're just interested in getting it installed. But first things first, let's go ahead and npm install all of our packages. And while we're waiting for that to run, I'm also going to install globally the AWS command line interface, which will get us ready to install a profile. So today we're going to be covering how to install Turing signing servers and run them locally. It'll be a little bit different if you're going to be actually deploying your serverless function or your serverless functions for the Turing signing server to an AWS profile. But even to run it locally, you'll need an AWS account with profiles locally. So those are prerequisites, having an AWS account, and then as we'll see, also a serverless account. So once this is all installed, which I'm actually going to update my npm through brew. We're also going to be, this Turing signing server is a serverless collection of serverless functions using the serverless.com. So we'll need to make sure that that is installed, and it's installed in the Turing signing server package itself, so we don't need to necessarily worry about installing it globally. You can, but we're actually going to do that through the package itself. But we need to create our own serverless account. So if we go to app.serverless.com, and I'm actually already logged in. But you'll create an account and then log in here, and then we'll actually, once everything's installed and updated here, we're going to log into our serverless account. So npx, which is going to let us access the local version, npx serverless login. Oh, and we actually need to reference an instance just because we have a couple different instances running locally, which isn't really needed here, but we'll just call instance 0, which will give us a trigger for the login. I'll log into my account, which will connect our desktop version, local version, with this online version here, which is super. We'll come back here in a minute because we actually need to create our app. So let's go back to the code for this. So now we've got our serverless set up. My tenant is tyvedh, which has my apps running right here. I'm actually going to switch. Move this over here for now. Switch. I have another org that doesn't have anything on it right now, called Tiny Anvil. So we're going to go ahead and just switch that. So you'll switch that to whatever your tenant is. We can keep these the same. We're not actually using Domain Manager right now. That's if you want to use custom domain names, but we're going to leave that off for now. All the rest of this is fine. We'll notice there's a certs thing for running in HTTPS, which I'll get to in just a minute. Just double checking the rest of this. We're not going to need any of that because we're not doing custom domains at the moment. But if you were to run custom domains, those would be where you would set those. And then we have all our different functions here. So that's should be good for that. When we go to run this, actually let's set up our certs first. So we need a directory called certs. And we're actually going to change directory into that search directory. And then I've got a gist here. For generating localhost self-signed certificates, and this just allows us to run HTTPS, which will solve for some issues that we might have for plugins that we use. I'm not sure if I necessarily need this for this particular project, but I like to run all my local host stuff through cert, so we'll paste that. And now if we list our directory, we should have a cert and a key. So if we go to our keychain access and we open up this directory, we need to drag in our cert to our system key, log in there, and now if we search localhost, I've already got one installed, but that would be the new one that we just put in. Let's go ahead and delete this one. We'll leave it for now because I actually need both of these. And then we need to get info on this and make sure that we set the trust to always trust. So every browser will trust this self-signed certificate, and sign for that again. And now we'll notice that if we kill that, those should both be fully trusted. All right, so now our certificates are ready. Go back to our code. So that's got our self-signed certificate. We're logged into serverless, and now we need to get AWS set up. So if we go to code AWS, we'll get our config and our credentials. So this is where we get our credentials to actually run our serverless function locally, or to even deploy it as well. I already have my serverless admin set up and ready to go. You will need to add that. So let's go to our console, and then go to IAM, and close up some of these just to clean it up a little bit. Let's add a user. We'll call this serverless admin 2. You can call it whatever you want. And we just need programmatic access. We'll attach existing policies, the administrator access. This is allowing everything, which probably isn't fantastic, but you can get more fine-grained once you actually go to deploy it. Though serverless does allow a method for not having to deal with these IAMs directly, but for running this locally, this administrator access is fine. Don't need any tags. Create that user. All right. So now I've got our new access key. So if we go here, let's actually just copy this and do 2. Copy that access key. Copy this secret key. Super duper. We're actually going to copy the same thing here for 2 and save that. And now when we actually go here, we need to change back one directory and export. I think it's up here somewhere. I don't remember exactly what it's called, but let's get this over a little bit. Export AWS profile serverless admin 2. So that's going to be the profile that AWS, or the local AWS instance running inside of serverless, is going to use when it runs locally. So we'll set that. And once we have that set, we should be good to go for getting the serverless up and running. There's going to obviously be an issue where we don't have the database configured yet, which is what we're going to do next after we update this environment. So this needs to be renamed to env.yaml. And then we have the instructions here for what each of these are going to be. So I've got some of this already set from my other instance. So we got a Turing vault address. This is where everybody's paying you when they're running contracts on your Turing server. The fees for running, fees for uploading, pending age, so how long do pending transactions exist, and then how many of those pending calls will exist before they start to flush. We're about to set up our database. That's where this will come in. And right now we're running Stellar Network on testnet, so we'll keep that as testnet. All right, let's go set up our database. This is kind of the last thing here. So let's go to RDS. I'm using Postgres. You can use whatever you feel comfortable. You would have to change some of the calls inside the serverless function, but Turing sending servers are kind of agnostic when it comes to the programming language or framework that you choose to use. But all right, so the next thing we want to do is create this Turing signing server Postgres database. I'm going to go with the latest and greatest. Get that nice free tier, and we're going to call this Turing signing server demo. We'll go ahead and auto-generate the password, leave the master username as Postgres. It's just a demo, so we don't need to scale anything. We'll go ahead and select that one. I don't need any backups or performance insights. All right, let's go ahead and create that. So I'll pop in here and we'll just wait for that to create itself. And let's make sure we get these credential details. Username and password. So if we go back to our instance here in our environment, password would be that, and the username is Postgres. You can obviously set something other than the root or master on this when you create additional Postgres usernames, but that's what it'll be for now. And while we're waiting, let's go ahead and set up our Turing signing server app. I'll just explain what it is. The Turing signing server, we've got this instance variable, which is coming from the instance variable in our scripts that we're going to run. So both in my deployment and development environments, I've got the capability of going from 0 to 4. So 5 different instances of this Turing signing server, just to provide you with a couple of different instances to be able to test multiple signatures and things like that, kind of a simulator, the real environment running Turing signing servers. In the real world, you're probably just going to want to run one of these yourself and then have other folks that are running them, and that's where you get your lots of different Turing signing servers. But for demo purposes, it's useful to have multiple. So with that, though, we're just running an index here of 0 through 4, 0 through 4. And then that number, save that file, that number is pulled across in this instance, which we use in several different places in this serverless.yaml file, which allows us to relatively quickly spin up different instances of our Turing signing server and call them quite easily. We're just going to be today dealing with the 0 index. So that's what we're going to assume both for our databases and for the serverless deployment. All right, so we've got that. Won't be able to see it again or change it, but we've copied it, pasted it, so we're good to go on closing that. And now we'll just wait for this database to get spun up. And once it is, we'll open up our Postgres admin file, pgadmin. So you want some GUI or CLI to be able to interact with this new database that we're spinning up. I use pgadmin 4. You can use whatever you're comfortable with, but we'll create a new server here, Turing signing server demo, and we're just waiting on these credentials that we'll add in once this deploys. All right. We've got our endpoint, port number. We're not yet publicly accessible. We'll get that in a minute. Let's go ahead and copy our endpoint here and put that into our code inside our YAML file. So that would be our host name. And the port number is that 5432. All right, so that's good. The database variable and bucket names and service name is all coming from this op instance here inside our environment. So service name, Postgres database. It just makes it a lot easier to deal with these different instances of this database, which we haven't created yet, but we will here in just a moment. Right now, if we tried to log this in, we wouldn't be able to. I'm going to go ahead and put these in. We're not currently publicly accessible, but I can go ahead and queue everything up anyway. And this will get stuck here trying to load up. But while we're waiting for that, we'll go ahead and make this publicly accessible. And the way that we do that is by changing our security group to include everything. Let's go ahead and change these security groups to include everything. So if we go to outbound and inbound rules, let's go ahead and make that a little bigger. Inbound rules set to all, outbound rules set to all. The last bit we need to do is make sure that this database is publicly accessible. So we'll just modify this real quick and have it publicly accessible and save that immediately. Once you make that modification, we just need to do a quick reboot. And it's modifying that now, so it should set our public accessibility to where we're actually able to gain access to this instance from the World Wide Web. Let's try this again. Should be able to gain access to it. Yep. So the first thing we actually need to do here is create a new database. And this will be called Turing Signing Server 0. And so for every Turing signing server that we have, we will increase that. But for now, we're just doing the 0 index. So we will save that. And we'll query tool and make our first and only table right here from our sql.sql file. It's got some helpful little scripts we can run. And we'll go ahead and create that table. And now inside of our schemas tables, we have the contracts table. And that's all we need to get access to, actually we'll save that one out. That's all we need to get access to our database. So now we're finally ready to call npm run dev 0, and that'll run our instance 0. We may get an error about serverless not having this application created yet, application not found. So what we need to do is actually create this app. So we go back to here and we do create app. And then we're going to click on full stack, Turing signing server, and deploy that. And then we should be able to go right back here and run npm run dev 0, and it should just work. And then we go to Postman. And we call this on localhost 4000. Actually, let's just call one of these. So we've got a GET request right here on the dev environment. Go to our Postman tool, make that a little bit smaller and grow it. Let's call a GET request on that 4000 dev, and this shouldn't return a whole lot, but it should at least be valid. We don't have any contracts uploaded yet, but here we go. We've got our Turing signing server running. So now you can begin to poke through the code, upload contracts, see all the different endpoints, but you've got a fully functioning Turing signing server running in your dev environment. If we wanted to spin up other Turing signing servers like 1, 2, 3, and 4, you would just need to go and make those new databases in here, much like we did. Just create new databases for all those, and then you should be able to just simply deploy all the new ones, and everything should work just great. All right, fantastic. That should be everything. If you have any questions, make sure and reach out. Let me know. Otherwise, good luck. Keep building. Submit pull requests. Let's get this thing out there. Thanks for watching.